Okay, last time we did odd power of sine, odd power of cosine, or even power, odd power. We took a power out, so that took a sine term or a cosine term out, so we had even powers. Great. Here, oh, again. Here we have both even powers, which is a problem because what is the point in pulling something out from an even power? Because you're going to end up with an odd power, right? It's like settling back to where you started. It's got to be a better way. I wrote 5 types last time. What are those 5? This is type number 3. Where both powers are even. If both of them are even, then you've got to use those 2 are missing today. We entered this entire philosophical conversation about double angle, half angle, and I said it's a matter of perspective. Can't let that go. So we have to use one of those. What we know is this. The other is that. So that is the only way. From that point onward, it is going to come down to using more trigonometric identities or some algebraic trick. Okay, so first, I want to rewrite that as a sine. Can I do that? Yes. Don't say u equals cosine squared and then put this as u squared. Life's not that easy, right? So I want to rewrite this. So I'm going to put sine squared in here. Or replace sine squared as 1 minus cosine 2x over 2 squared 1 plus cosine 2x over 2 dx. Good. Sure, one can FOIL, nothing wrong with that. But let's take a different approach. Maybe it will help us out. 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2 dx. Listening so far? Great. Again, we could FOIL and separate them into integrals. I'm going to do that if what I'm thinking is not going to work. I have a feeling that it's going to. We will see. So what is my thought process? Well, I've got 2, 2, 2, 8. Bring that out. Good. Done for you, yes. That will defeat the purpose. I'll call that A, call that B, A, B. What is A plus B times A minus B? Thank you.
A squared minus B squared.
A squared minus B squared. A squared would be 1 squared minus B squared cosine squared 2x. Dx. done FOIL yet, I feel like there is another identity that we can use prior to getting into foiling, which would be the alternative approach. Well, is there a way to rewrite that expression? How?
Sine squared 2x.
Sine squared 2x, agreed. 1 minus cosine squared 2x is sine squared 2x. Sometimes breaking terms apart might be a good idea. That would not have occurred to me, or that approach wouldn't be feasible had you not realized to split that term and write it that way, because I was able to go to a minus b times a plus b, use that algebraic trick identity to get to this step, and that because of that step. Good. Now, how is this step beneficial? How are we getting away with not foiling things? Can I erase this part over here? I'm going to split the integral. So distribute sine squared 2x. So sine squared 2x dx. Minus sine squared 2x cosine 2x dx. Good. One of them is pretty straightforward. Which one? So, by one of them's better than the other, but one of them's easier. Caleb's point of view is this is easier because no identity there. So what I'm going to do instead is pick u to be sine 2x. du, what is du? Is that it? Times 2. So 2 cosine 2x, is that it?
Over 2.
Over 2?
Over something.
Dx. Okay. U squared. The other part is over here. So that integral simply u squared times du divided by 2. Would you like to change your mind? Easier than this one. That is u squared integral of u squared is u cubed over 3, but I have a 2 really outside, so u cubed divided by 6. What to do with that term? Ask yourself again, what power does sine have? Even or odd? Right? Even power. If it is an even power, what type or which type should we use out of those 5 types that I wrote last time? if you are going to start with an even power, should we split? Let's put it that way. Should you split that sign, rewrite it some other occasion, saying no, we're not.
Already even.
It's already even. We split the sign into two terms, or cosine into two terms. When we have an odd power, we don't have an odd power, we have an even power. So, type 3, got to use the identity. So, sine squared 2x, I just erased it. We know that it's 1 minus cosine 2x dx. Yes? I can split the integral 1/2 dx minus 1/2 cosine 2x dx, and then that term, the term that's coming from u substitution. What is the integral of 1/2 dx?
Just a question. When it goes from sine squared to x, since the identity is sine squared x,
Thank you. It's 4. Not bad. What is the integral of 1/2 dx? Easy question, B.
X over 2.
X over 2. So 1/8. X over 2, do make that change. It's not 2x, it's 4x. Minus, I have 1/2. What is the integral of cosine 4x? Sine 4x over, okay, over 4, okay. And the last term is minus u cubed over 6. We can replace that u at the very last step. One over 8, x over 2 minus sine 4x over 8 minus sine cubed 2x over 6. I have a 2 in common, yes, so I can pull that out. So 1 over 16 x minus sine 4x over 4 minus sine cubed 2x over 3 plus 6. This ended up being, Michael, this ended up being relatively easy because of that one step right here. I split the sine squared term, wrote it as 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. So I can use a plus b times a minus b, the algebraic trick. Had you not done that, you would have foiled it. You would have gotten a huge expression. Then you have to integrate every single one of them. Painful, correct? So that's what I meant by using the algebraic trick. Okay, what is different about this problem compared to the other problem?
There are no powers.
There are no powers, right? So, well, we can't split anything up because there are no powers. So looking at notes, out of those 5 types that are road, which type does that fall under? Nathan? Type 5. So if you don't have powers, but you have sine, cosine, or sine, sine, or cosine, cosine, then you've got to take a different approach. What is that other approach? This. That is a trigonometric identity, right? Some like to call it product of sum, some product, etc. That would equal to cosine. Is it plus or minus? Is it a plus b or is it a minus b? Plus. Yes. Likewise, cosine a minus b would be cosine a cosine b plus sine a sine b. Good. I would like to retain that sine a sine b term. Agreed. So what should I do with those 2 equations? Subtract them. So cosine a plus b minus cosine a minus b would equal cosine a plus b minus cosine a minus b equals, those 2 would go away, minus, so minus 2, sine a, sine b, divide by -2 on both sides, sine a, sine b would equal to -1/2 cosine a plus b minus cosine a minus b. Good. You see what I did there? Right, you have that look.
Just trying to follow.
Why can't we just use like the bottom equation and then like,
Oh, you can, there's nothing wrong.
like
You
can we
mean
just
this?
subtract the 2 cosines over to the left and then like set that equal to, or is that like
Oh.
too complicated? Like down the line,
You mean
because you're trying
just
to,
keeping this?
no, because you're trying to get sine A, sine B by itself.
Uh-huh.
So if you subtract cosine A, cosine B over to the left, then you get sine A, sine B equals cosine A minus B, cosine A B. No, you're only using the bottom equation. Like, why are you using both equations?
Why am I using those 2? Or why am I using just this? Or why am I using just that?
No, like, why can't you just use the bottom equation that's cosine A minus B?
Why can't I use just that part?
No.
There are multiple bottom parts, Caitlin, which bottom are you referring to?
Okay, so the top 2 equations, that A plus
Well, how
B
about
minus
this? Let's resolve. We'll give it numbers. 1, 2, 3, 4.
Okay, so why can't you just use equation 2 and isolate sine A, sine B?
Okay, so if I had equation 2, and if I isolated sine A, sine B by itself, this has to go to the other side, right? Then you would end up having cosine A minus B minus cosine A cosine B, right?
Yeah.
You will take this, plug it in here,
And then it's just like repeating.
you're repeating the
Okay.
same process again, because when that comes in here, you have integral cosine A, cosine B form. You'll be going in circles.
Why are
Perpetually.
you using the cos A plus B and like A minus B equations and not the sine?
Hold that thought, we will get to that.
Okay.
For now, let's just do this. Just be patient, we are going to get to that. Bryce, where did you have an issue here?
No, I clicked one side. The gears started turning.
Okay, so I'm subtracting 2 from 1 to get that, so that I can solve for sine A, sine B. I can plug it in here. Now, by direct comparison, what is A? I could call A to be 7x, yes? B to be 8x. According to the formula that I just wrote, I can rewrite the integral as -1/2 cosine 7x plus 8x. Minus cosine 7x. No, erase this part.
No. Wait, I can take a photo, hold on.
That's fine, do it right. Minus cosine 7x minus 8x. dx. Right. So I've replaced sine 7x times sine 8x by that, by setting A equals 7x and B equals 8x. Good. Well, -2 can't come out, so -1/2 integral cosine 15x minus 7x minus 8x is cosine -x dx. Good. No matter what x value you take, cosine of -x is equal to cosine of x. Do you agree? Cosine is an even function. So you plug in -x, you'd still end up getting cosine x. So why not just replace that? If you don't want to, that's fine, but I don't like -2 today, so since cosine -x is equal to cosine x, even function, I can replace the second integral, or second term, that way. Now I just have to split and integrate. What is the integral of cosine 15x? Easy question.
Cosine 15x over 15.
Integrate. Oh, integral of cosine 15x. Sine 15x over 15. What is the integral of that? Simply be sine. Good. So the key here is recognizing that you're dealing with type 5.
Is the 1/2 still supposed to be negative or no?
Did I miss that negative? Oh. Minus
Does that have a name? That one right there. That you derived.
Yeah, there's it.
No, sorry, master is like, is number 4 a formula?
No.
Like that we should memorize.
It's a great question. Should we memorize it? If you want, you can't, but all you have to know is those two. If you know those two, you can pretty much get every combination that you want. Sine, 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 cosine, cosine. So it's up to you. If you want to write that down, go for it. It's not necessary. This, however, is in your reference table. Oh, we're clear. Now, the next problem is dedicated for Maggie. This will answer your question. Give it a try. Again, this problem is type 5. Depending on which you pick as A and B, the answer will differ slightly. I'm going to pick A to be 16x and B to be 8x. So, type 5, the types that I wrote. We want to move away from this product that I have to a sum. Reason being, if you have a sum, you can distribute the integrals. If you have a product, you cannot distribute the integral into a product. So we need a sum, it'll make life easier. Could we use the same to, well, actually 3 pointers, because you have cosine A, cosine B, doesn't match that. Sine A, sine B, doesn't match that. Agree? Okay. However, let's see if you remember what we talked about a couple of classes ago. Might have been last week sometime. Let's say I'm adamant about using this. I don't want to, but I hate to do it because the other ones got sin. This is cosine, cosine. If I'm adamant and I don't want to use the other identities, I want to stick with this. I'm going to argue I can still do it with one change to the problem. Only one change. Hint, how is sine related to cosine? Or how is cosine related to sine? Why do we call cosine cosine? Complementary angles, so if you want to find sine, what do? Cosine, sine.
And pi over 2.
Right, pi over 2. Sine 30 is 1/2. Cosine 60 is 1/2. How do you go from 30 to 60? 90 minus 30. Yes. So pi over 2 minus that angle. So I can rewrite this cosine in terms of sine. Agreed. Then I have sine. I can stick to the same two identities. If you're adamant about not using the other two. However, since I have the identity, I know sine A plus B is sine A cosine B plus cosine A sine B. Sine A minus B sine A cosine B
I saw that.
minus cosine A sine B. I don't know why such negativity. Everyone wanted to subtract. Last time I subtracted because I wanted the second term, which was sine A sine B. In this case, it doesn't matter which is which. Both terms have a sine and a cosine. It's just A and B swapped. I am going to add them together. If I add those identical terms, those will go away. 2 sine A cosine B would equal to the sum of those two. I divide by 2, I can rewrite that expression. So, 1/2 sine 16x plus 8x. Added them together, A is 16x, B is 8x. So plus sine 16x minus 8x times dx. Good. 1/2 integral sine 24x plus sine 8x dx. Agree? Integral of sine 24x is that you should know.
Oh, I know.
Yeah.
Cosine 24x over 24.
Is that it?
Yeah.
Sure.
Negative.
So integral there would be cosine 8x over 8. I have an 8 in common. If I pull that out, I would have 1 over 16 minus cosine 24x minus cosine 8x. This one would be divided by 3. But now, depending on how you did this, there is a possibility you have a different version of the answer. What would make the difference? If you had A and B switched, then your answer would look slightly different. Noah, did you use A to be 8x and B to be 16x?
No, I used AX is 16. Or yeah,
Did you subtract or add?
I added.
You
Or
added?
actually, oh no, I
You
subtracted.
subtracted.
Yeah.
So cases like this, it goes back to trigonometric identity. You know, the thing that I did here, had I not converted cosine of negative x to cosine x, that negative x would have just, you know, persisted. I would have had cosine negative x, use substitution, signs would change. So I can write this answer. If you had kept it as negative x, the answer would have been this. Negative 1/2 sine 15x over 15 plus sine negative x. So they have a different sign. Good. So possibility. Good. Okay.